Hi, today we're going to talk about factoring polynomials, and then we're also going to be solving some polynomials. So before we jump in with anything new, I'm just going to do a little review problem up here above. So I'm going to add in, what if I looked at having x squared minus 25 as my problem? Okay, on this one, does everybody notice that this one only has two terms? It has an a term, it's missing the b term, and then it has the c term. Okay, problems that look like this, you can use a shortcut for factoring. So instead of having to make the box, then we do have this new little formula called the difference of two squares. Okay, so making the problem quicker, we get to skip product, sum, factors. We get to go straight into, here's my two parentheses for the answers. So what you want to do is you want to think, what times what gives me x squared? Well, that would be x times x. And then the only way to get a minus is to have one negative and one positive, because a negative times a positive is a negative. And then the only way to come up with 25, that's the exact same thing, the exact same number, would be 5 times 5. So difference of two squares, that's what they're trying to tell you, because if you look over here in their answer, they have a minus b and a plus b. So you'll notice everything is exactly the same in the parentheses, except for one is a minus and one is a plus. Okay, and difference of two squares will work anytime you have an even exponent, as long as you only have two terms. You can't have three terms in the problem. So our very first example here under number 1, you're going to notice that it has only two terms. It has an x to the 4th and a negative 81. And x to the 4th power is an even power, so we are going to use our shortcut. So I'm going to draw my two sets of parentheses. And what times itself will give me x to the 4th? Well, that would be x to the 2nd times x to the 2nd. Because remember, when you're multiplying, you add exponents, and that would add for x to the 4th. So you have 1 minus and 1 plus. And then what times itself is 81? And that would be 9 and 9. So hopefully everybody is okay so far with what we've done. But we're not finished, because here's the catch. We still have two terms in each parentheses, and they have an even power. So we have to check to break them down even more. So this first parentheses, I'm going to break it down again. What times what gives me x squared? And that would be x and x. 1 minus 1 plus. And then what times what gives me 9? And that would be 3 and 3. Okay, my second parentheses. This one we're going to break down as well, but it's a tiny bit different, because does everybody notice instead of having a minus sign, it has a plus sign? So how is that different? Okay, so if you have, sorry, I just moved the screen. Let me scroll it back here for you. If you have two terms with a plus sign, then that means you have to have i's in your parentheses. Okay, and I'll show you why in just a second. Okay, so here, my two sets of parentheses. To get x squared, it's just x times x. Here we're going to do minus and a plus again. And then 9 is 3 and 3. But here's the problem. If I left it like this, if I multiplied it out, it would give me x squared minus 9. But I really want it to be x squared plus 9. So how can I make minus 9 become a plus 9? Well, if I multiply negative 9 times negative 1, that would switch it to positive 9. And what does that mean in relationships to I? Do you guys remember in our last unit that we said I squared was equivalent to negative 1? So if I came up here and I put an I with each one of these 3's, then that would give me negative 3i times positive 3i is negative 9i squared, and then negative 9 times negative 1, because I squared is negative 1, which switches it to positive. Yay! So moral of the story, if it has two terms with a plus, you're always going to put an I there. All right, so here's my factor answer. Boom. Now we have to do the solving answer. And hopefully from the last unit, you guys remember solving. You just take each parentheses and set it equal to 0. So x minus 3 equals 0. Add the 3 over, so my first answer is 3. And then x plus 3 equals 0. Move that over, and I get negative 3 as my second answer. X minus 3i equals 0. Move that over, and it becomes positive 3i. And then x plus 3i equals 0. Move it over, and it becomes negative 3i. So there's my 4 answers. And remember, for answers, highest exponent tells you the number of answers you should have. So our highest exponent in the problem was 4, so you better end up with 4 answers. And we did. So let's go to the next one. Okay, on this one, we don't have 2 terms anymore. We have 3 terms. So 3 terms, we do have to go back to the regular way of factoring like we did in the unit before. So product, sum, factors. So product would be 1 times negative 15, which is negative 15. Sum is the middle, which is negative 2. So remember, find me 2 numbers that multiply for negative 15 that will add for negative 2. And hopefully everybody says negative 5 and positive 3. And then we're going to go back and we're going to factor with the box. So we're going to put the first term in the first box, last term in the last box. Now here's the only thing that's different from our old factoring. In our old factoring, we said just to put an x in the middle with our 2 factors. But in this problem, we can't just put an x, we have to put an x squared, because do you guys notice in the original problem, the middle term has an x squared with it, not an x? So that is really the only difference with these polynomials, is that you're not just putting an x in there, you're putting an x squared or whatever that middle term happens to be. Okay, so now we do the GCF. So up and down. Up and down, they have an x squared in common. On the other side, can't start with a negative, so take a negative out. And then both of them are divisible by 5. Crossways. Take out an x squared. And crossways, take out a 3. So we're looking at x squared minus 5 and x squared plus 3. So now we have even powers and we have two terms. So we got to see if we can break them down like we did on example A. So if I try to break down the first one, is there anything times itself that will give you 5 that's not a decimal? And hopefully everybody says, nope. The only thing that will give me 5 would be 2.5, and we can't have decimals, so that's going to stay the same. On the second parentheses, is there anything times itself that will give me 3 that's not a decimal? And hopefully everybody says, nope, that one doesn't break down either. So this is my factoring answer. Solving. So let's take each parentheses and set it equal to 0. So x squared minus 5 equals 0. So x squared equals positive 5. Then we're going to square root both sides. Remember, when you take the square root of both sides, what symbol do you have to put in front? And hopefully everybody says, oh, you got to put a plus or minus in front of that square root of 5. And remember, with the plus or minus, that actually counts as two answers. Counts as a positive square root of 5 and a negative square root of 5. So then we'll go over here and do x squared plus 3 equals 0. Move that over and it becomes negative 3. Square root both sides. X equals plus or minus. Uh-oh, what happens when we have a negative under the square root? Hopefully everybody's thinking, oh, that means you have to have an I on the outside of the square root. And then this makes up my 4 answers because there's a plus and minus in front of each one. So that means it counts twice. So 4 answers, done. Okay, let's try another one. This time, before we jump in with product sum factors, if I look at all these terms, you should be thinking, oh, they have a GCF. What do they have in common? Well, all the numbers are divisible by 3. And every single term has at least an x squared in it. So I'm going to start by taking out a 3x squared. 3 divided by 3 is 1. 6 x's take away 2 x's gives me x to the 4th. Plus, divide that for 5. Take away 2 x's, which gives me x squared. Minus, divide that for 36. Take away both x's, so no x's left. So product would be 1 times negative 36, which is negative 36. Sum is 5. And factors is positive 9 and negative 4. So I'm going to make my little box. So first term is x to the 4th. Last term is negative 36. Then remember, when you put your factors in, you have to put an x squared with each factor. So 9x squared and negative 4x squared. So now take out up and down. You can take out an x squared. And you could take out a 9. Sideways, we could take out an x squared. Oh, can't start with a negative, so we got to take out a negative. And then we can also take out a 4. So we're looking at x squared plus 9 and x squared minus 4. All right. Once again, we can't circle this because we've got even power in 2 terms, so we got to see if they break down. X squared plus 9. Oh, we did that in part A. So I'm just going to recopy that down. It's going to go into x and x, minus and plus, 3 and 3. And then because it's a plus sign in there, we got to remember to put the i's with the 3's. X squared minus 4. I'm going to break that down. This one is a minus, so it doesn't need any i's, so don't put any i's on these. So you're going to have x minus plus And 4 would be 2 times 2. So there's my factoring answer. So now we're going to set each one equal to 0 and solve. Oh, whoops. Wait a minute. Sorry. Don't be silly like Miss Meyer was just silly. I'm going to erase this. What did I forget to put on my answer? Hopefully everybody says, oh, Miss Meyer, you did not put on the GCF. So make sure you go back here, take your GCF, and put that in front of your factoring answer. Now we can set each part equal to 0. So GCF, 3x equals 0. Divide by 3 and you get x squared equals 0. Square root both sides. So you get x equals plus or minus. And the square root of 0 is 0. And then x minus 3i equals 0. So x equals positive 3i. X plus 3i equals 0. So x equals negative 3i. X minus 2 equals 0. So x equals positive 2. And x plus 2 equals 0. So my last answer is negative 2. Highest exponent in the problem was 6. So I've got 1 answer, 2 answers, 3 answers, 4 answers, and the plus or minus brings me up to 6 answers. Yay! Okay. So the last 2 problems here on the front side, these are different because you're going to notice they don't have 3 terms. They have 4 terms. So if you have 4 terms, you're going to start by putting all terms inside a box. So I'm going to start off by putting a box down. Boom. First term, first box. Second term, second box. Third term, third box. Last term, last box. Now all you have to do is GCF, take out what they have in common. Up and down. Well, up and down, both numbers are divisible by 3, and each one has an x. Up and down, both numbers are divisible by 5. That's it. Sideways, each number is divisible by 9, and they each have at least an x squared. Okay, start with a negative, so I'm going to pull out a negative. And 3 and 5 are only divisible by 1. So you're looking at 3x plus 5 and 9x squared minus 1. Okay, can't do anything with 3x plus 5. There's no even power there, so I'm going to leave that alone. But what about the second parentheses there? We have an even power, so let's try to break that down. Well, 9x squared. I can get 9x squared by doing 3x times 3x. 1 minus, 1 plus. And then I can get 1 by taking 1 times 1. So there's my factored completely answer. So now we're just going to take each one and set it equal to 0. So 3x plus 5 equals 0. 3x equals negative 5. X equals negative 5/3. 3x minus 1 equals 0. 3x equals 1. X equals 1/3. 3x plus 1 equals 0. 3x equals negative 1. X equals negative 1/3. Highest exponent is 3. There's my 3 answers. Done. Boom. Okay, let's just go try it again. So start off with putting all 4 terms inside a box. So 6x to the third minus 16x squared, positive 21x minus 56. Then up and down, I can take out a 3x And I can't start with a negative, so take that out. And then the highest thing that goes into each number is 8. Sideways, I could take out a 2x squared. And the highest thing that goes into both those numbers is 7. So 3x minus 8 and 2x squared plus 7. Okay, can't do anything with 3x minus 8, so I'm going to leave that alone. My other parentheses, if I try to break it down, is there anything times itself that will give me 2? And hopefully everybody says no. So that one doesn't break down. We're going to leave it alone. So now all we have to do is solve. So set each one equal to 0. So 3x equals 8. Divide x equals 8/3. 2x squared plus 7 equals 0. 2x squared equals negative 7. X squared equals negative 7/2. Square root both sides. X equals plus or minus. Got to have an I because of the negative. And then square root of 7/2. Done. Okay. Moving on to the back. Woohoo! Almost finished. On the back, we're going to factor with 2 terms again, except for you're going to notice this one. 2 terms, but it doesn't have an even power. This is 2 terms with an odd exponent. So this one is called sum and difference of cubes. So let's go down here and use an example, and we'll look back and forth up at how to factor it from our example. So our first one is x squared plus 60, or I'm sorry, x to the third plus 64. Okay, we want to get, if we look back up here at our formula, we want to get from a to the third down to just regular a. So what is the opposite of third power? Hopefully everybody says third root. So we are going to start by taking the third root of each part. Now, how do you type that in on your calculator? On your calculator, you want to type in 3 first, and then use the X root button. Don't use the normal square root button. Okay, you have to use the X root button. And then you could type in 64. And if you do that, hopefully it'll tell you the answer is 4. And then on the first part, the cube root of x to the third, well, those just cancel out, and that gives me x. So wherever you see an a in your formula, you're going to plug in x. And wherever you see a b in the formula, you're going to plug in 4. Now, how do you know which formula to use? So in my original problem, does everybody see here that it was a plus sign? So you want to use the first formula right here that has a plus. So I have to scroll down, so I'll rewrite the formula down here for you to have. But the formula is a plus b, parentheses, a squared minus ab plus b squared. Which, once again, you don't have to have the formulas memorized. I'll give them to you on the test or quiz. You just have to know how to plug this stuff in. So the first parentheses, where I see a, I plug in an x. And where I see b, I plug in a 4. So I get x plus 4. Second parentheses, you want to square a. So if I square x, it becomes x squared. Minus, then take a times b. So x times 4 is 4x. Plus, and then square b. So b is 4, so 4 squared, well, 4 squared is 16. And the good news for you on these is that they never break down any farther after that. And we don't even have to solve this section. All we're doing is factoring, so we're done. Let's go to the next one. So once again, we're going to start off by checking GCF. Does it have a GCF? And hopefully everybody says, oh, yes, it does, Ms. Meyer. I noticed that each term has at least an x to the third in it. So we're going to take out x to the third, which will give me 27 x to the third minus 343. Now we can start with the cube root of 27x to the third and the cube root of 343. So that will give me 3x for A, and for B, I would get 7. This time the sign is a minus, so we're going to use the second formula, which I'll write it down here. A minus B, parentheses, A squared plus AB plus B squared. So you're looking at 3x minus 7. And then we've got 3x squared. So square 3 for 9, square x for x squared. Plus 3x times 7 is 21x. Plus 7 squared is 49. Done. Okay, one more. Does it have a GCF? And hopefully everybody says, yes, it has a GCF. It has a GCF of a number 3. So we're going to, oh, wait a minute. Darn it. I did it again. Go back to our last problem. In our last problem, you have to remember to put the GCF in front of our answer. So hopefully you guys have a better luck with that than I did. Sorry about that. Over here, we're going to take out a 3. So 3, and then I get x to the third minus 8y to the third. Cube root both parts. So I get a to be x and b to equal 2y. We're going to use the same formula that we did on the second one. But this time I'm going to remember my GCF, so I'm going to put that 3 out there right now. And then it's going to be x minus 2y. And then x squared plus 2xy plus square 2 for 4, square y, get y squared. And we are done.